We like to say English is a new programming language. Well, I made it be the case. I made it be true. So I can have an English file. I have linting, debugging, testing, compiling and running. I have everything that makes English a true programming language. And so the way I do it is that actually I'm using Qwen, large language models running here on my server locally. It's a 24B model. And it's just compiling my text into the language I tell it to compile into, and then it runs. And the way I did it is that it won't accept a prompt. It has to really be more programming like, but English is your syntax and it's not brittle. I made it work with R, Python, and Bash, and I don't know the Bash syntax much, but I've used R a long time ago, and these days I'm using Python, and so we'll do demos and explore how this works and you'll see it's really fun. It's really fun. So let's start with something simple. I'm just gonna make things up on top of my head. So let's start by saying this is Bash, and then list files here, biggest first. Okay, so just that. Then I compile. And so I have Qwen on my server that compiles it. And so it took this, and see how it highlights that for me. So it's nice. It compiles it and it assigns this section. So now it's listed. And so if I run it, and let me close that so we see well, now it's running it through shell, and so it actually listed it. I want it to look more like human. So list file here, biggest first, formatted nicely for human. Okay. And so you see this is stale now because I modified it. It builds a sort of graph for the language. And so now it changed the parameters and I have a lot more information. Okay, so this is nice. Now, what about and save as A? For I in A, take the second letter and print it. I don't know if that, I don't know if that's a construct that Bash can do well, but this is also a great way to learn it. So, like I'm highlighting the for loops, it's here, and so this will echo, and I guess that's how, it does it. And so if I run that, this is Bash, and it didn't print it, or I don't see. But another very interesting thing is that there's this syntax highlight, and it tells me what's ambiguous. So the scope of it is ambiguous. It is unclear if it refers to the current item A or the entire I or the entire A. Yes. So and print okay. So take the second letter for take I and store the second letter in B. Print B. That should be less ambiguous. And so I can retranslate or recompile. And so I'll see this, it's compiling down here. And so now you see the code has changed. If I run it, this is Bash. I have no A. Yeah, I have A. Saved as A, no. And store in variable A. That might have been a problem. So you see, like the dynamic is very, very much like programming. And yeah, now it's stored it. So we'll go simple. Display I. Okay. So the dynamic is very much like programming. So you're debugging, but you're debugging if you were clear or not. Okay. Oh, let's make it simple. List files, file names, list files names, and store in A. Oh, I did shift enter. Now it's gonna run just that. No, this is no good. Okay, run it again. And so there's debugging, and you're just kind of, learning to express yourself in a way that the computer will understand you. And so this worked, although why did it display A? This is A. Echo A for echo. Okay. And now what I could be doing, let's do something that is a job of bash. So let's do something like assign the phrase hello world to the variable var stuff. I don't know, stuff. I'll put a comma here just to be more clear. Assign this, assign, and then I'll do print stuff or show me stuff. Okay, run. So compiling first, and then it's always, looking. So this was here. Okay, this is good. But this show me stuff. Ambiguity. Ambiguous variable name. Stuff is lowercase, but the variable is defined as stuff uppercase. Bash is case sensitive, so it is not clear what you refer to. It's absolutely delightful to learn. If you do want to learn to code, it's wonderful. So you take that, boom, I'm clearer now, probably. Okay, cool. Now I could do something like let reverse be a function that takes an argument A, and then I could say inverse the letters in A and return A. Oh, store in inversed A, and then like that, inversed A. That makes sense, maybe. So let's run that. I don't know how to make functions in bash actually. So reverse, that would be what I decided to name it here. And you see, like I have my comments there. I don't need to read it. Oh, then I have to use it. So let me do reverse, then pass stuff to reverse and show me. So would I get something? It's compiling. Boom! Hello world in reversed. I would have, I could have figured it out, but like, this is nice. This is wonderful. This is really, really cool. Okay. So this works. Now let's go for R. Okay, let's remove that. Let's do this is R. So like I was saying, my first programming language was R, but I haven't used it in probably more than 5 years now, and so I forgot a lot of the syntax. And so let's do something like we will do a little data analysis and data manipulation and some things like that. This applies itself very well because usually R is done by scientists or domain experts, and they struggle with the syntax. Programming is powerful and clear and can automate things, but it can be brittle. It can be brittle to like get the syntax right. And so R has good libraries and tools to do, like statistics and data visualization. So let's get going. So first you'll need things like called libraries, and I know of two libraries, dplyr and ggplot. So we will use them. In R, you can install within the language. So you can do if, not if, ggplot2 is not install ggplot2. If dplyr is not install dplyr. The new lines is not necessary. Nothing is necessary. I designed it to be load ggplot. I designed it to be always just take in your English and it should work. You have to learn how to express yourself clearly, but that is not this program's fault. So we could do something like there is a very common and popular data set called IRIS, the IRIS data sets. It's a data set about flowers. They're using it often to do examples, and it's in R. Like it's already there. So we can say load the IRIS dataset in df. Okay, so now we just have that. Let's run this. This should change itself completely to be recompiled in R. This is R. And so we see this is really a R file. And I see that it has dplyr. Maybe I need to open another. So target, show the code. Show code, boom. And like I've never done that in R because I was too lazy, so I'll just do this and then I would comment it out because I didn't remember the syntax to do require namespace. So these are the types of things that is very powerful, very amazing to have, to be able to express just like that. And you know, like if this is just like a way to prompt, but it feels like a very sane and sober way to prompt. So I'm looking at this, you know, now I'm feeling like these old guys that looked at their assembly language, even though they use a compiler. Now I'm looking at it and I'm like, yes, this is just right, cool. But it was faster to express, right? I mean, it's actually very interesting. Print df. Okay. So let's run that. And here we're always like rerunning it from the beginning all the time, but I made it work in the REPL too. It's just that the model has less context, so it's not as good. By the way, let's remember that this is all working on a consumer GPU. All that we saw here is done. This is RD programming. This is the R programming. Yeah, so this is all running on kind of top of the market GPU, but still, boom. Okay, so look, we have a data set, we have numbers here. And then what we will do is that we will analyze this data. And so the first thing we'll do is do a plot. We'll look at this data. And so we will plot petal length against sepal length. Okay, so we'll say plot, well, what I just said, right? Plot petal length against sepal length. I don't know if it's gonna work well. Usually I work in RStudio. Well, usually a couple years ago when I was doing that, I would be in RStudio. Now here I don't know. Yeah, is this right? No plut, waiting for plut. Okay, so this won't work. I just tried to install this extension. What I'm gonna do is that I'm gonna do plut blah 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 store in P, then I'm gonna say save P as PNG. And I used to never remember, and I couldn't code it right now. I never remember how to do that. And so, but no worries, we have our friend here. And there we go. And here we have again some ambiguous stuff. And so GG save. Okay, P plot. Can I go look at my plot? Here I have a plot. And my plot is empty. Okay. Save this. Da 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 da. I'm kind of surprised it's empty. Interesting. No file name. Save P as p.png. One thing with ambiguity that I've found happening is that it won't recompile to the same thing, but that's why it's spinning here. So if the dependencies of tree doesn't show that you have that something that depends on it broke, it'll just work. This is weird. How do I have that problem? Okay. Sepal petal. Ah, it doesn't know the name of my columns. Haha. And it's using them wrong. It doesn't have the context. Okay, interesting. So this is the name of the columns. Interesting. If I don't want to be precise about it, we need a strategy, something like store in SL the call name that closest match sepal length based on string distance. That's a bit crazy, but now I'm curious, and so I want to see what that does. Retranslate. I can close that here and I can see the results. Oh, that wasn't a good idea. Phrase close mat. Oh, yeah, that's not clear if I do close match. Okay, retranslate. So I can hover and look at this, and so now it's trying to do some adist. I don't know this, but what about if we print it then, right? If we do print SL, then we can, oh, I think we can debug. Oh, can we debug? I don't know if we can debug in R. Let's debug. A compile is already running. If I close that, and I do debug. Okay, let's not debug, let's just run again. So anyway, it really feels like when I was coding by hand, just debugging. But this time, yep, so this worked. This worked. Okay. So then I want to do that. with pl I could have written it right, but we're doing we're exploring it. And then store in pl and then plot pl column against sl column and store in p. Maybe that's clear enough, because the poor Quen already running. Can I stop that? Okay. Oh, it's because no, it's not because nothing. Run. We'll see the data. So I could remove the data. We'll see sepal length. This is discourage used instead. Pa-pam! We now have a plot, but that's an ugly plot, and we can do better. Let's try to go high level and say, let's remove all these instructions, and we want to say normalize the column names. I don't know what this will do. I guess I should have just stopped to be lazy and call them by their real name. It's like if I was telling open this file on my computer and I'm not giving the real folder name and the real file names. I mean, what can they do, right? Show code. So now they will be, they're all lowercase and stuff. And then I guess I could print them here. No, I can't. That's interesting. Okay. Yeah. So we'll do that. We'll show me df. We'll run. And then this is running. Is it? Okay, this is it. Now, look at that. I'm just gonna cheat. Oh, I lost the names. Boom, cheating. Then I'm gonna do comment. We will keep it like that. Okay. Then we do make a plot of equal length to oh no, they have the same name now. Normalization was bad. We don't do that. Okay, well, I guess we'll use our brain. Let's use the brain. Is it coming out now? Okay. I'll use the real name. Bam. Okay, so I'll talk clearly. Now, imagine I don't want to show me the df anymore, so I'm commenting it out. And now I do make a plot stored in variable p with sepal length, sepal length as x and sepal width as y. Color the dots by species and take p, save as p.png. Okay, try that. So it's kind of at this nice place where you don't have to learn the syntax, but you have to learn the concepts and you have to learn to speak clearly. And so it's quite interesting, and it's a very nice exercise in trying to figure out, you know, what you said. Was it clear that actually is what you're saying clear? And with this highlight, it's really nice because it really tells you, it helps you, it guides you. Are you clear? Are you not clear? It guides you. And so when I was playing around just before, I also saw that I could change the plot. Nice, okay. Now we have a real plot here. This is cool. Okay. Now I could do something like take P and make its background white. Okay, let's try that. Run. And so you see that this is now stale. But that was a new sentence. I was wondering if the chunk after would be stale, but it didn't show. Nice. Now it's white. Okay. Then I could say and remove the border from the main plot area. I don't know. I don't know how to do it. I don't know on top of my head. I know it can be done. This already running. Always does that. Seems like I'm better removing this. This is too big for us. Yes. Run. And so that's it. That's programming in English. Right? You, like, that would be brilliant for students, for kids. Did this work? It went back to gray. Went back to gray. What did you do? Interesting. If I remove it, I want to convince myself that it's running. After we should do some stats. If I remember the stats. Okay, P. No, lost my gray background. Is it guiding me? The instruction to remove the border from the main plot area is ambiguous. It could refer to removing the axis line, the panel border, or the outer plot border. Move the panel border. Maybe. I don't know. Let's try. So see, like, I'm learning the vocabulary on how to be clear about this. I like it. It's more tedious than vibe coding and just telling a coding agent, you know, just do that. But it's nice. I think I like it. I can change the model. Let's try to have like a super big remote model. What does it, maybe I can I unpin? I want to recompile the whole thing. There's maybe a better way to do that, but that's what I'm doing right now. Boom, run. Okay, it's compiling. Compiling. Is it done? No, it's still surveying the program. It's gonna survey the program forever. It's using my default, so right now it's probably using Fable 5. Linting for ambiguity. Ooh. Do I have more? No, just that. Linting for ambiguity. Interesting. Yeah, and then after I want to do stats, but we have to look at the plot for that. And so I will want to measure the average. I will want to see if there is a difference in average sepal length between all three species, and it should be a significant difference between the red and the two others, and the two others should have no difference. And that would be a t-test, probably. I'm rusty in my stats even. So compile this to programming language R. Let's go. You can do it. It's a little long, little slow. Qwen was doing much better. Qwen was faster. Taking forever. It's probably reasoning, over reasoning. Yeah, and so this is open source. I've put it on my GitHub. The way it works is that it has these buttons, these commands. It gets sent to the AI model. And actually, I did that to my terminal too. So you see my terminal here. If we make the terminal bigger, like this, with that, no, this, yeah. So if you do that, and then you do list files here, biggest first, and then I could do list 10 files. Okay, boom. And so what's happening for this one is that there's a hook, and if this gets into the error state of the bash, then the hook captures it and sends it to Qwen, and Qwen rewrites my English into a REPL, and then boom, it's just happening. And I did the same for R and Python, I think. And so if I do IPython and I do something like, import, well, this is normal Python, whoops, import numpy, and then I can do create a array of 10 numbers, save in Z, and then boom, see, This is wonderful. This is absolutely wonderful. And then this is in my terminal. It's so cool. Ah, this is so cool. Anyway, yeah, so you can just be like import the good library for data frames. I knew it was gonna do pandas, but pandas is not the good one. The good one is maybe polars nowadays. But yeah, so now I have PD, and so I can do like make a data frame of 2 calls 10 values. And so in this case, it knows it's in the terminal, right? So it's kind of making things up more than in the script. Yeah, so we have that, and then R works too. So I could do load ggplot2, boom, load iris. I think load data function. I don't know. I think it sees the output. No. Load dplyr, R, and see now what it used. I don't have it. Data iris. No, interesting. Iris, come on, get the iris dataset in memory here. Could not find data. Oh, so it may not be a fully real REPL. It should be though. I don't know. I don't remember how. But yeah, create a data frame of 2 calls 10 vals, and so we have that, and then we can use our normal code in R, and then that would bring these type of things up, or we can do a scatter plot of the f with ggplot2. Boom, boom. See, wonderful, absolutely wonderful. I love it. Now, is this make a plot stored in? You're there. 2 more to go. This takes forever to compile. Oh my god, I'm not gonna use that one again. That was bad. I mean, we're so close now, right? We gotta wait for it. I'm supposed to have a line-by-line functionality here. English. I can do enter like that. Boom. And so I can do to add, take 2 args and sum and return sum. I don't know what it's gonna do. If I do shift enter this. No. Yes, I want this one. Don't want Quen. Quen is too slow. Did I break it? I probably broke it. Whatever. Already running. I'm giving up. But I think you've seen what this is. I'm also supposed to be able to load from one file to another and all these things. It's a complete programming language, and you can see this highlight. You can see, I can do test if I do something like, for example, add 8 and 7 is 9, and then it will check it, like it will run that and it will create an assert with that. Now I wish I can show you. So this here, boom. Okay. Let's delete this. Let's close that. Let's close that. Now, if I do run, we're back with Qwen now, because Qwen is the GOAT. I want to look at the code, show code, to add, for example, blah, blah, blah. Yes, so you see this here, assert, blah, blah, blah. Now test, it's actually running these assert, and it's passing. So you can create a test. For example, add to and set for is, let's do a mistake. And so you can see that if I run the test, it's compiling the stale part. It's gonna run the test and I'm gonna have a failure. See, boom, failed, and it's red. Example failed. Isn't it wonderful? It's absolutely wonderful. Anyway, that's all I had for today. Have a good one.